If you aren't a researcher or a professional statistician, statistics might be scary to you. What if you were a few clicks away to get an entire analysis with a detailed statistical report? Even statisticians use this trick to make their work easy and fast. All you need is a dataset with value and a little help of features or functions from Excel. Hello there, this is Farihatul Mim from Exceldemy, your one-stop for Excel blog posts, discussion forum, templates, and VBA-related answers. We have a dataset with the names of 10 students and their respective scores. Based on their scores, we will learn how to create a descriptive statistics table in Excel. In the process, we have used Excel 365. You can use any other available Excel versions as well. Let's get down to the video. "13 statistical terms in Excel. We will use these 10 score values to get these statistical terms. We will manually use different functions and formulas for that. Let's try sum first. As we know, we can just manually type sum function and add the entire range C5 to C14. Enter. So we get the sum value. As for count, the process is pretty much similar and it will get us the value that the number of samples is 10. Now the maximum value among the scores are, using max function, we can get 53. As for minimum, in the same way, we get the minimum value as 10. Now for range, we need to subtract minimum from maximum. So let's select F7 minus F8 as reference. So we get our range as 43. So we can say that range is the difference between the maximum number of the sample and the minimum value of the samples. As for mean, we can just manually use the average function. Let's select C5 to C14 again, and 29.50 is our mean. Median goes the same way using the same reference, and we get our median as 29. Notice that if the number of samples is odd, which isn't that we get from the count function, then the exact value of the middlemost sample would be the median. If the number is even, which is in our case, then the average of two middlemost samples are added as median. Now for mode, mode.sngl, tab our reference, enter. So our mode is 21. Value occurring the most times among the samples are labeled as mode. As we can see, 21 is available 2 times in our dataset. Now for standard deviation, we can easily try stdv.s function and use the same reference. Enter. Now standard deviation is the dispersion value of the samples from the mean value. Now before going into the latter 4 calculations, let's add a different format for count. Press on Ctrl to select more, finally mod. And from the Home tab under the number group, click on the decrease decimal button so that we get exact integer value. Now to calculate standard error, we can just use the formula equals the standard deviation reference, which is F13, divided by the square root value of the number of samples which is achieved from the count function before. So our standard error here is 4.32. For standard error, we considered that the confidence level is 95%, which means you are sure 95 of 100 data values will remain within this range. The considered error of 5% is calculated here based on the standard deviation value. Now sample variance is using var.s function using the same reference of C5 to C14. Sample variance can also be calculated as the square result of standard deviation. Now curtices will be calculated using curt function. So we are getting a negative value. To understand curtices, we need to take help of a graph. Let's see this picture here. Now the normal distribution line is added with a continuous black line. The dotted line with the highest peak is positive curtices and the arc with corresponding thicker dots are for negative curtices. So we can say curtices is positive when values close to mean are in a very high frequency. It will be 0 when the normal distribution curve maintains its original height. Furthermore, our negative value here represents the frequency of values near mean are lower than it is for standard normal distribution. Now let's place this image here. As we can see, our curtices value is negative, so it means the frequency of our sample values near mean are lower than it is for standard normal distribution. Now for skewness, let's try its own function again and use C5 to C14 as reference, and we get a positive skewness. Let's understand what does it mean. As we can see from the image, we can see there is positive skew, symmetrical distribution which is 0 skew and negative skew. Our positive value means the peak of the graph which is being shown at the mod line is higher than the mean line which is the dotted line here, and the peak shifts to the left side. Now for 0, its position remains the same as the mean. As we can see, mean, median and modes are all within the same line. Negative value means the right shift of the peak. Now let's minimize the image as well. Now manually calculating all these one by one will do us no good. We can use Excel add-ins to get all the values automatically. Let's see how to do that. To use Excel add-ins, we need to enable Data Analysis tool first. For that, let's click on Alt-F-T to open Excel options window. From here, go to Add-ins category. Here, Manage will be Excel add-ins. Click on Go. Now from here, add-ins available list, click on Analysis ToolPak and go along with OK. Now if we go to Data tab, we can see that within Analysis group, we get Data Analysis. If you go to Developer tab, from the Add-ins group, you can click on Excel Add-ins and enable Analysis ToolPak as well. Now let's go back to Data tab. Let's click on Data Analysis. As we get the Data Analysis window, let's choose Descriptive Statistics, just what we are looking for. Okay. For input range, the values will be C4 to C14, grouped by columns since our values are organized within one column, labels in first row since we have our column header here. You can add new worksheet if you want your descriptive statistics table in a new worksheet. Let's go along with output range so that it's easier for us to follow. As for location, let's select H2. Click on summary statistics since we want all the values as a statistics table. And here we can see confidence level for mean is by default added to 95%. Just as we discussed beforehand. Okay, now if we select these two columns and double click on it, we can see them with more precision. Here, let's select F13 to F17 and from the Home tab under the number group, let's select increase decimal so that it's easier for us to compare. As we can see, all the values are exactly as we calculated. Now, this table is generated automatically without using any functions or formula, rather only one feature in Excel. So it's easy, right? Now you might be thinking that we have tried the descriptive statistics table for one column only. How about to create a descriptive statistics table for multiple columns in Excel? Let's try that using this dataset. Using the same method, go to Data tab and from the Analysis group, click on Data Analysis. Choose Descriptive Statistics, OK. And for input range, here our range will be C4 to E14, grouped by columns, labels in first row. Output range will be G2, OK. Now we can see all the values. Let's select column G to column L and double click on it so that it's easily visible to us. Now from the table, it's almost similar to our previous example. The only change here is we can see that mod for physics and chemistry are not applicable. It is due to the values within the physics dataset and chemistry dataset. There are no values that are found more than once, which is why mod values are not applicable in this case. From this, you can use any of them according to your convenience. You can practice this with the help of the Excel file in the description box below. Let us know if you could do it in the comment section. Share your suggestions and feedback as well. You can visit our website exceldemy.com and reach out to our forum for all your VBA or Excel related problems free of cost. Stay tuned by subscribing to the channel and clicking on the bell icon. Like and share the video if it helps you. Thanks for watching.